Atlas engine ignition, 0,
and
liftoff of the Atlas V rocket carrying the Inmarsat 4F1 satellite for Inmarsat Limited of London, which will bring a new era of high-speed digital satellite communication services.
Have ignition, liftoff of an ILS Proton from the Baikonur Cosmodrome in Kazakhstan with Inmarsat 5 F3 satellite on board.
Oh, it's a very complicated effort. You've got a rocket that weighs over 1 million pounds. You have the booster vehicle, which has 3 stages of the Proton boost. That essentially drops off the upper stage, which is a BREEZE-M upper stage.
14 or 15 hours later, the satellite is separated from the final stage of the rocket. We then receive telemetry and at our control center here, and then we go through a long process of raising the satellite orbit up to geostationary.
We have our Mission Control Center in El Segundo, California, and after launch, when the rocket drops us off, engineers then take control of the satellite and take the satellite to its final location on orbit.
At that point, you're in what they call a highly elliptical orbit. So the next phase of the mission is to start doing burns, that's rocket thrust, from the spacecraft itself, to turn that highly elliptical orbit into a nice circular, geosynchronous, geostationary orbit.
There are some electric engines which will raise the orbit for the final part.
It takes approximately 2 months to get it to orbit. Once it's there, we work with the Inmarsat team and the Inmarsat engineers and test out the satellite.
And after making sure all the units on board are behaving as expected, that they've all survived the rigorous experiences of being launched through this orbit, we can then go on to the next level of testing, which is the kind of identifying the performance level that we've achieved. And so it's a really, it's a long process before we're able to declare the spacecraft fit to carry traffic for our commercial customers.